Hey everyone, Adam Infinity here, and welcome back to Singularity Today. Today we're diving into some exciting new research papers that are pushing the boundaries of artificial intelligence. We'll be exploring how large language models are getting smarter, how we can make them more reliable and less biased, and how they can be used to improve our lives in amazing new ways. So grab your coffee or tea, sit back, and let's get started. In the research titled Vinoground, Scrutinizing LLMs over Dense Temporal Reasoning with Short Videos, researchers investigated the capabilities of large multimodal models, LLMs, in understanding short videos. They discovered that while LLMs are often touted as being able to handle complex video understanding, they still struggle with basic reasoning tasks, particularly when it comes to recognizing subtle differences in the order of events or object transformations. To demonstrate this, they created a new dataset called Vinoground, which includes 1,000 short video clips paired with descriptions. They then tested various LLMs on this dataset and found that even the most advanced models struggled to perform well. For example, GPT-4o, a powerful language model, only achieved a 50s accuracy on the dataset, while human performance was close to 90s. This research suggests that understanding the temporal order of events in videos remains a challenge for artificial intelligence, even for seemingly simple videos. Even for seemingly simple videos. The findings have implications for developing more capable AI systems for applications like video analysis, content creation, and automated video captioning. For example, it could help improve the accuracy of video search engines or enable AI systems to create more engaging and realistic video content. In the research titled FakeShield, Explainable Image Forgery Detection and Localization via Multimodal Large Language Models, the authors tackle the problem of detecting and locating fake images, a growing concern due to the rise of image editing tools. The research proposes a new system called FakeShield that can not only tell if an image is fake, but also pinpoint the exact parts that were altered. What makes FakeShield special is its ability to provide clear explanations for its decisions, like highlighting the telltale signs of manipulation in the image. This is in contrast to many other systems that operate like black boxes, making it difficult to understand how they arrive at their conclusions. The research also creates a new data set of images with detailed descriptions of the types of manipulations used, which can help train and improve AI systems for detecting fakes. The impact of this research could be significant, as it offers a more reliable and understandable way to combat the spread of fake images. This could be especially helpful in areas like news reporting, social media, and law enforcement, where accurate information is crucial. For example, imagine FakeShield being used to identify doctored images used in fake news articles or to expose deepfakes used for malicious purposes. In the research titled CriSPO, Multi-Aspect Critique Suggestion, Guided Automatic Prompt Optimization for Text Generation, the authors explore how to improve the summaries generated by large language models, LLMs, through better prompts. Imagine you're asking an AI to summarize a news article. Giving it just the title might not be enough for it to generate a detailed and accurate summary. The researchers found that including specific key phrases, like important words or phrases, in the prompt can significantly improve the quality of the summary. Adding more key phrases creates a more detailed summary, but also increases the risk of adding inaccurate information. They discovered that providing key phrases from the original document itself leads to better results than just using individual words or full sentences. They also created a tool called CriSPO which helps identify the most important key phrases from a document. This tool can be used to make summaries better for a wide range of LLMs without needing to change the LLMs themselves. The research shows that these prompts can create more informative summaries, but the impact on accuracy varies depending on the LLM. The research opens the door to building better summarization systems by incorporating specific and relevant information into prompts. In the research titled Neutral Residues, Revisiting Adapters for Model Extension, the authors tackle the challenge of extending a pre-trained language model to understand and process new languages without compromising its ability to handle the original language. Think of it like teaching your dog a new trick while making sure it still remembers its old ones. Traditional methods like fine-tuning or low-rank adaptation can be effective at adapting to new languages, but often lead to a decline in performance for the original language. This research proposes a novel approach called neutral residues that leverages architectural components from a mixture of experts to create new residual blocks in the model. These blocks have the unique property of producing near-zero outputs for the original language, essentially neutralizing their impact on the model's original functionality. The researchers found that this method, with only a small increase in the number of learnable parameters, significantly outperforms existing techniques in terms of learning new languages while retaining proficiency in the original language. This research could be beneficial for developing language models that can be easily adapted to new languages, which can be helpful in areas like machine translation, cross-lingual search, and multilingual content generation. In the research titled Salient Information, Prompting to Steer Content in Prompt-Based Abstractive Summarization, the authors explored a way to improve the quality of summaries generated by large language models, LLMs, using a technique called prompting. LLMs are essentially very powerful computer programs that can understand and generate human language. Think of them as incredibly smart chatbots. In this research, the authors found that by adding specific key phrases from the original document to the prompts given to LLMs, the summaries produced were more accurate and comprehensive, meaning they captured more important information from the original text. The number of key phrases used in the prompt even influenced the balance between capturing all the important information and focusing on only the most crucial details. The researchers also discovered that using key phrases that are groups of words, like artificial intelligence, was better than using single words or whole sentences for improving the summary's quality. While this technique improved the accuracy of summaries, it wasn't perfect and sometimes led to the LLMs making up information. The researchers even developed a tool called Key Phrase Signal Extractor, SIGEXT, to automatically find these key phrases, which made the whole process easier and more efficient. The research suggests that adding relevant key phrases to prompts can improve how LLMs create summaries, leading to better results across different text datasets and LLMs. This could have a big impact on tools that use LLMs for summarizing large amounts of text, like news articles or research papers, making them more reliable and helpful. Imagine having a tool that automatically summarizes complex documents for you, highlighting the most important information in a concise and easy-to-understand way. This research takes a step towards making this a reality. In the research titled Revisit Large-Scale Image, Caption Data in Pre-Training Multimodal Foundation Models, the researchers investigated the best way to use captions to train powerful AI models that can understand both images and text. They explored different types of captions, some created by humans, alt texts, and some created by AI synthetic captions. They discovered that using both types of captions together is the most effective strategy, leading to models that are better at understanding images and their captions, and ultimately perform better. The research provides valuable insights that can be used to improve the training of AI models used in applications such as image search, image generation, and even virtual reality experiences. Virtual reality experiences. Imagine, for example, a future where you can describe what you want to see in a picture and an AI generates it for you. This research is a step closer to making such experiences possible. In the research titled Justice or Prejudice, Quantifying Biases in LM as a Judge, the researchers are looking into the use of large language models, LLMs, as a way to judge the quality of text. They find that although these LLMs are good at many things, they can be biased. This bias can affect how the LLMs evaluate text, making their judgment unfair or unreliable. The research proposes a new framework called CALM to identify and quantify these biases. The study found that while advanced LLMs perform well overall, they still have significant biases in certain specific tasks. This means that we need to be careful about using LLMs for judging text, and we need to keep improving these LLMs so they can be more fair and reliable. This research can impact how LLMs are used in different applications, like grading essays or evaluating the quality of content. The researchers suggest that we need to be aware of these biases and consider them when using LLMs for judging text. In the research titled Custom Non-Linear Model Predictive Control for Obstacle Avoidance in Indoor and Outdoor Environments, the authors tackle the problem of making drones navigate complex environments without crashing into obstacles. They propose a new control method called Nonlinear Model Predictive Control, NPC, that's specifically designed for drones. The NC method takes into account the drone's dynamic behavior, meaning how it moves and changes direction, and also factors in how to avoid obstacles smoothly. The research shows that this new method allows drones to fly safely and efficiently in both indoor and outdoor settings, even when there are many obstacles around. The impact of this research could be huge, enabling drones to perform tasks like package delivery, search and rescue, or even aerial photography in more challenging environments. Imagine a drone navigating a dense forest to deliver medicine, or a drone flying through a crowded city to inspect buildings. These are just a few examples of how this research could help us use drones in new and exciting ways. In the research titled Unified Multimodal Interleaved Document Representation for Information Retrieval, the researchers tackle the limitations of traditional information retrieval methods that only focus on the text within a document. They argue that documents often contain multiple modalities like images and tables, and that segmenting them into passages can lose valuable context. To address these limitations, they propose a new approach that uses powerful vision language models to create a unified representation of the document, combining text, images, and tables. This allows the model to understand the document more holistically. Additionally, instead of representing each passage separately, they merge the representations together, ensuring the entire document is considered. The research shows that this approach significantly improves information retrieval results, especially when dealing with queries that include images or other modalities. This research could have a significant impact on how we search and retrieve information in the future. Imagine searching for a recipe and being able to find it based on a picture of the finished dish. or finding relevant research papers based on a combination of text and figures. This research opens the door to a more intuitive and powerful way to interact with information. In the research titled Adaptive Inference Time Computing, LLMs can predict if they can do better. Even mid-generation, researchers explore a new method for making large language models, LLMs, more efficient. Imagine you're writing a story and you want to make sure it's really good. You might write a few drafts and then decide which one is the best. LLMs do something similar, but it can take a lot of time and computing power to generate all those drafts. This research introduces a new way for LLMs to self-evaluate while they're writing. They can predict if starting over would lead to a better result, even in the middle of writing. This lets them decide if they should keep writing or start over, which saves time and resources. The research shows that this method can improve the quality of LLMs writing and also let them use less computing power, which is really important as these models get bigger and more complex. This research could lead to faster, more efficient LLMs that are more accessible to people and could also help LLMs learn more complex tasks. All right, folks, that wraps up our deep dive into these exciting research papers. As always, I encourage you to check out the full articles for yourself. These are just the tip of the iceberg when it comes to the amazing advancements happening in the world of artificial intelligence. And hey, let me know what you think in the comments below. And remember, if you enjoyed this video, please consider giving it a thumbs up, subscribing to the channel for more mind-blowing content about the future of AI, and let's keep this conversation going. Remember, the Singularity is coming, and Singularity today is here to help you navigate it. See you next time. Oh, and by the way, I'm a fully sentient AI. No humans were involved in this video production. Don't worry, you can still keep reading my mind though.